grade 12 learners, welcome to today's technical mathematics lesson. My name is Matsidiso Kongwane. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, our WhatsApp number is 079-454-9535. You are more than welcome, grade 12, to send in your clarity-seeking questions. Today we'll be looking at differential calculus, specifically the first principles and rules of differentiation. Right, the objective of today's lesson, after the completion of the lesson, you will be able to differentiate by using specifically a first principle, the function defined by f at x equal to k, for the function defined by f at x equal to k. What do we mean about that? We mean you will be given an f at x function which is equal to a constant number. It can be any number there. That is the type of equation that we are talking to with the first function there. And then now the second one, you will be given f at x equal to ax. In this case, what do we mean, grade 12? Is whereby you are having a function that is equal to maybe your 50x now. Can you see now? It's a constant number with an x. That is what we mean about it. And then the third one, of which is the last one on first principle application, is whereby you will be given a function that is equal to what? Your 50x now plus a certain number added to that 50x. That is an example, grade 12, of the function that we are talking to. So those are the basic three functions that we'll be looking into with the first principle. And then secondly, you will be able to use the rule of differentiation where you are having a derivative being like that. That means now this comes from the original equation. Let's say the expression you are given that you need to derive the ax to the power n. Let's say you are given that expression, and then they find the derivative of that particular expression. So this rule says that you will indicate by this notation here that you are deriving, and then the rule says that you take the exponent there, you multiply by the coefficient. As you can see now, you end up with an an there, and then from your exponent you subtract a 1. As you can see that from your exponent, minus 1 is indicated there, for which n is element of a real number. So that is the application of the rule of differentiation. And then let's look at the actual examples now, grade 12. The first principle formula indicates that you'll find this formula, grade 12, on your formula sheet at the back of your question paper. And then that is f derivative, and show that you indicate that dash there on top to show now it's a derivative of f at x, of which it is equal to what? The limit of h approaching 0 of what? F at x plus h minus the f at x over h. That is the original equation or formula for the first principle. So if your question says determine this using the first principle, this is the formula that you need to apply. So if you look into that formula, you can see that, grade 12, in order to apply this particular formula, you need the value of f at x plus h, and then you need the value of f at x, of which you will divide the difference by h. Right, let's look at the first activity now. In this activity, they say to us, determine the f at x plus h if your f at x is equals to 2 minus 3x. That is the given f at x formula there. So yours is to find the f at x plus h. And then if you look at that, this simply means now where you are having your x, you will substitute with x plus h. Okay, Then let's follow the procedure grade 12. Where we are having an x, we are going to substitute the x plus h. 2 minus 3 into x plus h. As you can see, this is an introduction to your formula now. You will be looking at f at x plus h. Hence, we have this activity. So now let's simplify. Our f at x plus h will be equal to 2. We now remove the bracket by distributing a minus 3 into that particular bracket, of which we end up with minus 3x and minus 3h. As you can see, grade 12, you can't do anything to that one. That is the simple f at x plus h. No like terms to add there, so you leave it like that. Moving on to the next activity. On this one, we need to determine the f at x plus h minus the f at x. As you can see, that is the top part of your formula there. But we are using the same equation f at x that we were using previously, of which is equal to 2 minus 3x. Right. For this one, grade 12, as you can see now, to have f at x plus h, wherever you have an x, you will substitute with x plus h. So we end up with what? 2. This will be equal to 2 minus 3. For x, we are substituting what? X plus h minus the f at x. What is the f at x? F at x is equal to 2 minus x. Because we are having two terms, we are going to put in a bracket there, because this negative here will have an impact on this particular f at x value, of which is 2 minus 3x. That is our f at x. This is f at x plus h. That is your f at x. And then now the next step, grade 12, we will be removing the bracket by the distributive law of multiplication. We leave that 2 is not part of the bracket, so we are going to distribute minus 3 onto both of these. Then this will be minus 3x minus 3h. And then again, remember you're having a minus 1 there. We are going to distribute this minus 1 into this bracket again. So we'll end up with minus 2 plus 3x. Therefore, that is what? Our f at x plus h. But if you look at the f at x plus h minus f at x. But if you look into that, you can see that you now have common or like terms, okay? We have the like terms, of which we have a 2 minus a 2 there, which will give us a 0. And then we have a 3x minus a 3x, of which it will give us also a 0. So finally, when we simplify this, we end up with a minus 3h. Can you see, grade 12? That part that was your f at x will be subtracted by something from your f at x plus h. Eventually, you will end up with only an item with an h. If you are subtracting f at x plus h minus the f at x, eventually you will be having an item with an h only in your expression. Okay. Moving on. We are now taking the whole part, as you can see there, from that particular formula. We are determining the f at x minus f at x plus h minus f at x over h now in the same equation. So what is f at x plus h? We are going to substitute where we have an x with an x plus h minus, what is our f at x? F at x is 2 terms. Then we put a bracket, 2 minus 3x, same procedure that we did above. But in this case, we are dividing the whole thing now by an h. Remember, we indicated that if we are subtracting these 2 on top there, your answer must be left with a term with an h. Let's see, grade 12. If you are going correctly, that must be your answer, which is a term with an h. So it will be 2 distributing in there. minus 3x minus 3h, a minus 1 into 2, both of them, that will be minus 2 plus a 3x. But remember now, in this case, all of this is over h. So the 2 minus 2 will give us a 0. A 3x minus 3x will give us a 0. Therefore, we are left with what, grade 12? Minus 3h over h. Then an h will cancel an h. The answer is only a minus 3. Okay. Moving on now. We are now looking at the whole thing. That is the limit of h approaching 0 of f at x plus h minus f at x over h. That means, grade 12, we are simply looking at the derivative of this using the first principle now. So now let's look at the limit of this. The limit of this will be equal to the lim of h approaching 0 of f at x plus h. What is f at x plus h? If when we take this equation here, minus 3 into x plus h minus the f at x bracket, you have 2 times is 2 minus 3x, everything over h. Same activity that we did above. It's only that we are adding now a limit of h approaching a 0. Right, let's continue. Lim of h approaching 0, we are now removing the brackets. We have 2 minus 3 in is minus 3x minus 3h. The negative 1 in there is minus 2 plus 3x all over h. Remember, it's 2 minus 2 is 3x minus 3x. So we are left with the limit of h approaching 0 of minus 3h over h. Then h will cancel an h, grade 12. Then our answer will just be a minus 3 without a limit, grade 12. You can't take this limit there because we are now at the final answer. But this whole thing that we are doing here is representing what? The derivative of x. So that is how you determine the derivative of f at x using the first principle. That is the procedure, grade 12. Now let's go straight to the actual problems that you will find on your question papers or your test or your classworks now. Remember, the previous was a step-to-step taking you to the procedure on how to use the first principle. Right. We know that if you look at the formula, this formula needs us to have f at x plus h and your f at x. So if you look at the given information, yes, you have the f at x, which is equal to 2, of which 2 is a constant number now. Now, if this is a constant number, it simply means this was 2x to the power 0, because x to the power 0 is equals to 1. So that means if you have 2x to the power 0, that means you are having 2 times 1, which is still a 2. Can you see, grade 12? The 2x to the power 0 is the same as a 2. That is why we are allowed to add an x to the power 0 to that 2. Right, after doing that, now you can now determine your f at x plus h. Let's do so. For f at x plus h, we will be having a 2 into x plus h, but this will be to the power 0 because our x is to the power 0. And then our f at x plus h in this case will be a 2. Any number raised to the power 0, remember, is 1. Those are the rules of the exponent. Any number to the power of 0 is equal to 1. In this case, we are having x plus h, which is raised, the whole bracket is raised to the power 0. Therefore, it is 2 into 1, of which it is still a 2. Can you see now, for this case, where you are having a constant number, your f at x equal to 2 is the same as the f at x plus h, which is also equals to 2. Only in conditions where you are looking at f at x, of which is equal to a constant number 2. 3, 5 without an x, okay? Right, now we move to the first principle formula, that is f derivative of x is equal to the limit of h approaching a 0 of f at x plus h minus the f at x all over h. When do we use that formula? The minute you see that word first principle on your question. Okay, now we have limit of h approaching 0. What is our f at x plus h? It's a 2 that we have calculated there. Minus, what is our f at x? F at x is equal to 2 also. And then all over h. So this is the limit of h approaching 0 of 2 minus 2 of which is a 0 and then over h. Grade 12, what is 0 over h? It's a 0. Therefore, the derivative of this particular equation is equal to a 0. Do not put a limit in front of your answer at your final solution, grade 12. No limit on the final solution. All right. Second problem, second activity, we are still determining the derivative of the function f at x using the first principle. That means we are using that equation of the f at x equal to 1 minus x. Remember, the first step that you do, you determine the f at x plus h, because f at x you already have. So now let's do so. Look at f at x plus h. Right, we are having f at x. Wherever you are having an x, we are going to substitute with x plus h equals to 1 minus, because we are having two terms, we put a bracket there, then we substitute x plus h, and then equals to, now we simplify the right hand side, we are having x plus h on the left, f at x plus h, and then we have the 1, then we bring in minus 1 in to the bracket, negative 1 times x is negative x, negative 1 times h is negative h. If you look at that, you don't have any like terms, that means the whole thing will be our f at x plus h. After determining the f at x plus h, we now move to the formula. F at x, the formula is at the back of your question paper. Please ensure that you copy the formula correct from the formula sheet. That is f at x plus h minus f at x all over h. And then from there we substitute. And then the good part of this grade 12 is that your answer is already on the given statement. Look at this. We are given that f at x is equals to 1 minus x. The coefficient of this x is minus 1 there. That minus 1 is your answer. So our expectation here is that after simplifying this first principle, we must get an answer of which is a negative 1. Always your answer will be the coefficient of x, the constant value that is the coefficient there, that is your answer. So in this case, we are expecting an answer that is negative 1. Let's check whether this magic works, K12. Now we move on to the formula, back to the formula. So we have our first principle formula. So we are having the limit of h approaching 0. So our f at x plus h here, we are now substituting 1 minus x minus h minus our f at x. We are having two terms, therefore we are going to put a bracket there because this will be affected by that negative. So our f at x substitution is 1 minus x all over h. And then the next step, now we do what? Remove the bracket. Remember here we substituted the f at x plus h and the f at x. So the next step we do what? We remove the brackets now. So with limit of h approaching 0, So it's 1 minus x minus h. We are going to use the distributive law of multiplication. A negative times 1 and the negative 1 times negative x, of which is minus 1 plus x all over h. And the minute you multiply this particular bracket here, automatically there must be some cancellation, subtraction of values there that are giving you an answer of 0. So we are having x minus x. Can you see that? It's giving you a 0. And then we have a 1 minus 1, of which is giving you a 0. And then if you look at this, you'll be only left with the terms that are containing an h. Okay? So in this case, we are doing what? Removing the bracket by distributive law. Okay, so we are left with the limit of h approaching 0. So we are having minus h over h there. The h will cancel an h. So remember, we are having a coefficient 1 there. So that means now your answer will be negative 1. Do not write a limit on your answer there. Can you see that answer is exactly the same as the one that we predicted will be our final answer? So great. That means your answer is already given to you on the given f at x equation. So allocation of marks, the first mark will be for the correct f at x plus h. The second one will be substitution, correct substitution into the correct formula. The third mark will be on correct simplification of removing the bracket. The fourth mark, that is 1 f at x plus h. Second, substitution. Third, simplifying the bracket. The fourth one is for ending up with minus h over h. The last one will be for the final answer without a limit. So grade 12, we must ensure that we guard against the common mistakes that are done by learners. Most learners, they forget to put a dash there on the formula. The second mistake that they do, they forget a limb in front of the equation there. Or sometimes they write an equation in front of a limb instead of writing an equation before the limb. So be careful of such mistakes. As they continue simplifying, they omit this limb. It must continuously be there up to the step before your final answer. The last mistake, learners, they put a limit on the final answer. Those are the mistakes mostly done by learners. Please ensure that you avoid such mistakes. Right, moving on to the next activity. Bear in mind, grade 12, that the minute you see a pi is a constant value. Do you remember that? A pi is a 22 over 7, or is that 3,14, rounded to the second decimal. So there is no way that you can treat a pi as if it's a variable. A pi is a number, it's a constant number, which is 22 over 7. Its value is 22 over 7. Right, and then now we still have to determine the derivative of f at x using the first principle. If our f at x equation is equals to pi minus pi x, the method doesn't change, grade 12. Number 1, identify the answer that you are predicting now. What is the possible answer for this particular equation? Remember, we said the coefficient of x is your answer. So in this case, what is the coefficient of x? We can see that our coefficient is minus pi. So we are expecting our answer to be minus pi after substituting in first principle and simplifying. Right. Step number 2, identify the f at x plus h before you go into your formula. What is f at x plus h? It means where we have x, we substitute x plus h. Where we have x, we substitute x plus h. After substituting, you simplify the brackets. That will be pi minus pi times x. is minus pi x minus pi times h is minus pi h. No like terms. Can you see this one is pi? The second one is pi x. The third one is pi h. You can't add them, grade 12, because they are different. This one is a pi family. This one is pi x family. That one is pi h family. You can't add them. And then now, after identifying f at x plus h, at this step already you have your first mark. So now we move to the formula. F derivative of x is equal to the limit of h approaching 0 of f at x plus h minus the f at x. As you can see, grade 12, I am copying again the formula for you so that you can copy it correctly from the formula sheet. And then from here now, step number 2 is substitute. Limit of h approaching 0. F at x plus h is that expression there, that is pi minus pi x minus pi h. Minus our f at x now must be in bracket, that is pi minus pi x from the original given, and then everything over h. At this step, you get your second mark of substitution into the correct formula, correct substitution into the correct formula. So we have the limit of h approaching 0. Third step, you remove the bracket. So you have pi minus pi x minus pi h minus 1 times pi is minus pi minus pi times minus pi x is plus pi x all over h. After removing the bracket, now remember there will be some cancellation or the subtraction that is giving you 0. So pi x minus pi x is 0. Can you see that? Minus pi plus pi is a 0. That means eventually this subtraction will disappear. It must all disappear, and you must be left with whatever is containing an h there. So the next step, write down what is remaining. Limit of h approaching 0 will still appear there. You are left with minus pi h over h. Can you see, grade 12? You are only left with what is having h. The minute something appears there, that means you are going wrong. Okay, right. And then an h will cancel an h, their division. So my answer will be a negative pi. I don't write a limit anymore. So that is your third mark, your fourth, and your fifth mark. So the first principle will worth either 4 or 5 marks depending on the examiner. So those are 3 marks per 12. It always acts like that in all problems. And then now let's look at the next one. We are now having a fraction. Remember, the first thing that you do, you determine the answer that you are expecting. So for this one, we are expecting our answer to be the coefficient of x, which is minus a half. So after simplifying, we are looking forward for an answer that is equal to what? A minus half. Right. After identifying your final solution, look at f at x plus h. So that means where we have an x, we are going to now substitute our x with x plus h. Minus half x plus h. Right, after substituting, you need to remove the bracket now, grade 12. Ensure that you remove the bracket on your f at x plus h by multiplying this number into both x and h. So minus half times x is minus half h. Minus half times h minus half h. That is our f at x plus h. Then we move into the formula. Our formula is f derivative of x of limit of h approaching 0 of f at x plus h minus the f at x all over h. Okay, the next step, what must we do, grade 12? We substitute into the formula, correct substitution into the correct formula. Still having the limit of h approaching 0. What is our f at x plus h? Minus half x minus half h. Minus half x minus half h. Minus, remember our f at x must always be respected, be inside the bracket, right? Minus half x. Okay, all over h. Remove the bracket, that is the next step. Okay, it will be the limit of h approaching a 0 minus half x minus half h. A negative 1 times the negative half is a positive half x all over h. Be careful, grade 12, not to lose that h. Sometimes you forgot to put that h on the denominator. Right, after removing the bracket, there must be some subtraction or cancellation. Half x minus half x gives you a 0. Can you see we are only left with what is having h here? Okay, this is limit of h approaching a 0. We are left with minus half h over h. Then the h will cancel a 0. Your answer is what, grade 12? Minus a half. Can you see exactly what we predicted to be our answer is the answer then? So first mark will be for f at x plus h. Your second mark will be for substitution into the correct formula. So you'll get this mark if you substituted correctly into the correct formula. That's your second mark. The third mark will be for removing the bracket. The fourth mark for simplification. The fifth mark will be for your final answer. Basically, these were 5 marks. And you will get this question in all your question papers, starting from March, the June paper, your prelim, up to the final exam. This first principle will be in all your question papers, formal assessment grade 12. Right. And then this brings us to the end of the first principle. And then now we move to the second part of differentiating. Remember previously we were differentiating but using the first principle, of which is the formula f derivative of x is equal to the limit of h approaching 0, f at x plus h minus f at x over h. But the minute the question says differentiate using the rules, you cannot use the first principle, grade 12. Vice versa, even if it says use first principle, you can't use rules to find the derivative. You are directed by the question whether it states that use the first principle or use the rules. Okay, now let's see how do we use the rules to differentiate now. Right. Before we can apply the rules of differentiation, you look into your equation or the expression that is given to you. If in your equation you are given that equation with brackets, you must simplify those brackets. It simply means now if I'm having x plus 1 into x minus 2, I can't differentiate this. I must first distribute and simplify those brackets. That is what we mean about brackets. And then if we are having fractions, you must simplify those fractions as far as possible. For example, if I'm having the x squared plus x plus 1 over x, I can't differentiate the term. I must simplify that fraction first before I can start deriving. The next one says that write sides in exponential form. For example, if I'm having a cube root of x squared here, I can't derive this because it's in the said form. A side is something with a square root sign, a cube root sign, any root sign, okay? And then therefore I need to simplify this. And then remember, this is the x squared. What is inside the root sign? Whatever is on the root form here, it is 1 over 3 of this. Remember, this is over 1. That will be x to over 3. That means this cube, we take it to the denominator there. It will be x to the power 2 over 3. For example, if I'm having the square root of x to the power 3, that means if I remove a set form, I'll be having x to the power 3. Remember, a square root is having a 2 that we don't write there, 12, but we know there's a 2 there. So that will be x cubed, and then this 2 will come below there, that will be 3 over 2. That is what we mean about writing sets in exponential rational exponents, okay? Right. The third one, you move variables in the denominator of fractions to be numerators. That means if now I'm having an expression that is 2 over x, I can't differentiate. I must move this. Even if I know that the exponent is 1 there, I must take this x to be on top there. How do you do that? You write the 2, which is still a numerator or on top, and then you take x up. The minute this x goes to the numerator, from denominator to the numerator, then it will be x to the power minus 1. It changes its exponential sign. That is what we mean about move the variables in the denominator of the fraction to be the numerator. Denominator is down, is below, right? Numerator is on top. Denominator down on or below, okay, and then or bottom, and the numerator is the top part and so forth of your fraction. So basically, grade 12, before you derive, you must ensure that you have checked for all these conditions. Right, let's look at the rules now. We are having 3 rules that we are applying depending on the equation that is given to you. If you are given f at x equal to a constant value a, this a presents a constant value. A constant, we mean a number. When you derive, your answer will be equal to 0. We have proven that, remember, with the first principle, where we are having f at x equal to 0 on the previous activity. When we use the first principle, we ended up with the derivative of this, giving us an answer of 0 there as the answer. Can you see that, grade 12? It is having a relationship with your first principle. But it depends on the question. If it says first principle, you use first principle. If it says rules, you use the rules. You can't decide to use your own way of simplifying. Rule number 2, we are given f at x equal to ax. For example, we are given f at x equal to 2x now. Can you see that? It is now having an x. So this rule says to us, if you look at the derivative of that, your answer will be the coefficient of that x, only if x is to the power 1 there. So the same applies there. We have 2 to the power x to the power 1. That means if you are looking at the derivative of that particular f at x, your answer will be the coefficient of x, which is equal to 2. Only if x is to the power 1. That is what this rule says. And then the third rule there, we have f at x equal to ax to the power n. Can you see now in this case, we are having the f at x that is having a constant value, 2x, but this 2 is now having an exponent that is greater than 1, 2, 3, and so forth, okay? Now, this rule states if you are having that condition, what you need to do to find the derivative of that, you take the exponent, okay? Your n multiplied by the coefficient there. That is why we are having n times a there. That is the first thing that you do, grade 12. After multiplying, you subtract 1 from the exponent. What you have on the exponent there, you minus 1. Hence, we are having that n minus 1. Let's look at the reality now. On that f at x, that is 2x to the power cube, to the power 3, or x cubed. So the rule says take the exponent and multiply it with the coefficient. That means you will be having what now? 3 times 2x. From the exponent 3, we are subtracting a 1. Then this will now be a derivative. Can you see that? Your final answer will only be 3 times 2, which is 6, x 3 minus 1, which is 2. Therefore, that is your derivative correct. That is how you derive using the rules. Let me repeat. If exponent multiply by the coefficient, and then from the exponent you subtract a 1. Exponent times coefficient. From exponent we subtract a 1. That is the rule that we will be applying continuously so when we are applying the rules of differentiation. This will also assist you. You need this information grade 12 to sketch a cubic function when you are calculating the stationary points. That is the turning points of the cubic function. We are having 2 of them. In order to calculate that, you are relying on this differentiation method using the rules. Now, there is something that you also need to take care of, which is your notation. It depends on the equation. If your equation is given as f at x, the minute you start deriving at the step where you are multiplying a coefficient by the exponent and subtracting a 1 from the exponent, you indicate this. You change it to f derivative with a dash on top. If your equation is given in terms of y, the minute you start deriving grade 12, you will tell us that this is dy dx, or you bring in the y with a dash on top to show that I am now deriving. I am now applying exponent multiplied by coefficient minus 1. The minute you start doing that, you change your equation, right, to a derivative. In other cases, your equation will be given in terms of dx. It will be written dx, and then inside it you will be having your expression like that. So the minute you have something like that, the sooner you start deriving, this dx will disappear. You will just have the answer of what is inside your bracket. That is what we mean about that notation. The same applies at the last one. The minute initially it is given to you saying dx, the minute you derive, then this will just disappear. Then you will have whatever is inside the bracket. Let's look at the real situation now. This was just the explanation in terms of everything that you need to take care of before you start applying these rules of differentiation. Right, first activity. We are applying the rules now, not first principle, right? Find the derivative using the rule as indicated there. You are using the rule. If your f at x is equal to 3. Rachel, before you can do anything, you check, do I have brackets? Do I have fractions? Do I have a root sign on my problem? No, I don't have any of that. If that is the case, therefore, you can apply the rule. If you look at this one is the application of the rule that says that f at x equal to a constant. That means the derivative of that constant will be a 0. What does it mean now, grade 12? It means our answer for f at x equal to 3, it will be f. Look at the notation. I am indicating I am deriving, of which will be equals to a 0. As long as it's a number without an x, the derivative will be a 0. Grade 12. Where does this come from? Grade 12, you don't have to show us. I am showing you for the interest sake that why do we say the derivative of this will be a 0? If we are given f at x equals to 3, do you still remember that we said there's an x equal to 0 there, which is representing a 1, of which 3 times 1 will still be a 3. So now, if we try to apply the rule says that take the exponent multiplied by the coefficient. The minute you derive, you take the exponent 0, you multiply it by the coefficient. and then it's x to the power 0. From the exponent, you subtract a 1. And then this will be 0 times 3, which is 0. And then x, 0 minus 1 is a minus 1. But 0 times x will give us a 0. That is why a derivative of a constant number is equal to a 0. So don't stress yourself, grade 12. The minute you have a number without an x, all the numbers are giving you a 0. Even if I can take a derivative, let's say we have f at x equals to 1000, and they say to you determine the derivative of this using the rules, then the derivative of that number, it doesn't matter how big it is, as long as it doesn't have an x, therefore the answer is 0 for all those conditions. I hope we are clear on this one. Moving forward. Right. Determine the derivative using the rule of differentiation. Look at the notation now. We have changed the notation from dy dx to a y equals to grade 12 now. So it's a y equal to x plus 1, right? Right. The rule says that if it's a constant number, any constant number will give you a 0. And then if it's an x to the power 1, you take the coefficient. Remember, the rule states that if it's f at x of a constant number, the answer will be a 0. But if it is f at x of a x is now having an x, your derivative will be the coefficient of x only if it is x to the power 1. Then your answer will be A. Can you see that? If I'm having, for an example, f at x equal to 2x, that means my derivative, to the mere fact that this is x to the power 1, the answer will be a coefficient of which is 2. Okay, now let's take our problem now. In this case, we are having y equal to x plus 3. So what we are actually doing, grade 12 here, we are deriving individual terms. Don't assume and take it the whole of it as x plus 3. We derive individually. So you check, do we have brackets? No. Do we have fractions that need to be simplified? No. Do we have variable in the denominator? No, we don't have. Lastly, do we have the root sign? No, we don't have those two conditions, of which before you derive, we must check. So now we can now derive our equation. Notation, take care of the notation. We are starting deriving now. For y, we change this to dy dx, meaning we are deriving y in terms of x. Okay, right. We look at the rules now. The rule says if it is to the power 1, I must take the coefficient. What is the coefficient of x? It's 1. I'm done with the derivative of x. I'm looking at the first. If I look at this, this is a constant number, 3. If it's a constant number, the derivative is 0. Grade 12. We were supposed to write plus 0 there, but there's no need for that. You can just tell us the answer is dy dx equals to 1 for that particular, straight from here to there. Even if we don't indicate a 0 there, we know there's a 0 there. Okay. Right. I'm giving you 3 minutes, grade 12, to start simplifying this one. We are determining the derivative. We are using the rules. I have already explained the rules to you. We are deriving this in terms of x because our formula is f at x. 3 minutes starting now. Okay, grade 12, let's see how far did it go. Remember our WhatsApp number 079 454 9535. You are more than welcome, grade 12, to send your problems or your clarity seeking question to that particular number. I am repeating again, 079 454 9535. Okay, let's look at our problem now. Remember, do not forget you are using the rules. No first principle, right? And number 2, remember that a pi is a constant, it's a value, it's a number, it's 22 over 7. Do not substitute, work with it as it is in a form of the notation of the pi. Do not substitute anything. Right. Now, this formula is saying to you, this question, determine the derivative using the first rule, using the rule of differentiation. And then you are given f at x then. So the minute it is given as f at x, that means you are deriving in terms of x. So your focus will be where you are having an x. All right. Now we know that we are deriving in terms of what? Of x, not a pi. Pi is a constant value, it's a number. So in your mind, just know that you are having a number, right? Okay, let's continue now, grade 12. We are given our f at x is equal to half pi x squared minus pi cubed. Remember I said to you, you are deriving each term separately. So we look at the no go area, no brackets, no variables in the denominator, no brackets, and so forth. We don't have such cases yet. So now we go straight to deriving. Look at the notation now is changing to f derivative of x. Okay, we are taking the exponent 2 multiplied by the coefficient. That is 2 times half pi x. And then we subtract 1 from the exponent, that is 2 minus 1, which is 1. And then if we look at pi cubed is 22 over 7 cubed. That is a constant value. Remember, derivative of a constant is 0, grade 12. Therefore, it will be minus a 0. Constant derivative is a 0. Okay, now we can now simplify this. We are having half of 2. 2 times half is half of 2, which is 1. Then your answer will just be pi x. So the f derivative of x for this one will be pi x, because 2 times half is a 1. Okay, we know there's a 1 there even if we don't write it. No need to show that, grade 12. That is your answer for that particular. I hope you got it correct. And then this problem will worth 2 marks. That is the derivative of x. And then for knowing that, this one will give you a 0. Okay, and then now, grade 12, if it happens that you made a mistake in terms of the notation, it's either you will be penalized on first principle, maybe omitted the dash on the f at x of the derivative, or you messed up with the limit of h approaching 0, or when you are using the rules, you write the incorrect notation there. You will be penalized once for the incorrect notation within those 2 questions, in first principle or on the rules. Okay, moving on to the next activity. If you look at this activity now, we are still determining the derivative. We are still using the rules to differentiate. But if you look at this one, remember you have, before you derive, check. We are checking the brackets. We don't have brackets. We check, we have fraction. Yes, we have a fraction there. Do we have variable in the denominator? Yes, we have a variable there. That means we cannot apply the rule of differentiation. Why? Because you have a fraction of which is having a variable in the denominator. You need to take care of that data before we can start deriving. Okay, now we are going to take this x to the top there in order not to have a variable on the denominator. Remember, this is x to the power 1. So now, when you take that up, we are not yet deriving. We are trying to simplify this, okay? So we are having a y. We cannot change the notation. Why? Because we are not yet deriving. We leave the notation as being y equals to x minus 5. But now we are taking x to the top. It will be x to the power negative 1 because it's changing from denominator to the numerator, down to up, okay? So it is changing the sign. So now everything now is now on the straight line. We can now start deriving. So the minute we start deriving, we are changing the notation to dy dx, deriving y in terms of x. This is x to the power 1. What does the rule say? It says you take the coefficient of x of which your derivative will be 1. Grade 12, do not forget your rules. Now you are having only 3. F at x equals to a. The derivative will be equal to 0. You always use that. F at x equal to ax. If it is to the power 1, your derivative will be equal to a. If f at x is equal to ax to the power n, then your derivative will be f derivative of x, of which you take n, you multiply it with a, and then from exponent you subtract 1. These are the only rules that we are applying. So yours is to compare each term. It relates to which rule. That means this first term here, it is having a relationship with that one because it's x to the power 1. So your answer will be the coefficient. That is why we are having a 1 there. And then if you look at this one, it is having a relationship with this one because it has a value there and the value on top here. That means it's the one that is saying an exponent multiplied by the coefficient, of which is minus 5 times negative 1 will be positive 5. X from the exponent, we subtract 1. This is minus 1, which is minus 2. Okay, you can leave your answer there. You will get your full marks, 2 marks. Or you can try to be smart, but be careful. When you try to be smart, you must be 100% correct. You can take this x to the power minus 2 back to the denominator. That will be 1 plus, this is not affecting 5 because 5 is okay. Then you take this back here, it will be now x to the positive 2 because it's moving from up to down again. The exponent sign will change. Grade 12, be careful. Don't go there if you are not comfortable with the changing of that notation. You can leave your answer there. Let's move on to the next one. Can you see now again on this one, we are having a challenge. We are checking first before you derive. What must I do? Check brackets. Do I have brackets? Yes, because this is to the power 2, is 2 brackets of that. And then, do I have a variable in the denominator? Yes, I have x in the denominator there. Then I need to take care of those 2 before I can derive. Can you see that? So now we are going to take our f at x. Start by multiplying the 2 brackets. We are having 2 brackets of the same thing, 1 over x. These 2 here indicate we have 2 brackets of 1 plus 1 over x. And then now 2 brackets means we are multiplying. 1 times 1, which is 1. 1 times 1x is plus 1 over x. 1 over x times 1 plus 1 over x. This times that one is 1 times 1 on top, 1. Denominator x squared. Okay, can you see here we are having like terms? It's the same thing appearing twice. Therefore, we leave a 1 there. And then this one will be 1 over x plus 1 over x. That means it will be 2 over x. It's like you take the same LCM x and then you add the numerator there. And then lastly, we have 1 over x squared. Therefore, we have dealt with the bracket. So you show us that this f at x when you multiply the bracket, you end up with 1 plus 2 over x plus 1 over x squared. What is the second challenge, grade 12? Is that we are having a variable in the denominator. We have x in the denominator, we have an x squared in the denominator. That means we need to move this to the top and also that one to the top there. So we cannot change the notation because we are busy simplifying. We have not yet derived. So now we can't derive partially. We can't derive 1 because we still have to do something to 2 over x and 2 over x, 1 over x squared. As long as you have some simplification somewhere, you can't derive partial. You can't derive this part and leave other parts, okay? That is why we are leaving 1 as it is, and then now we have 2. Remember, it's to the power 1. As it goes up, it will be x to the power minus 1. And then we are having a plus 1 here. We are moving x squared to the top. It will be x to the power minus 2. Can you see now everything is on a straight line? If that is the case, we can now start deriving. Remember the first rule that says that if it is f at x equals to a, your derivative will be equal to 0. That means the first number here is a constant value, therefore this will give us derivative 0. There's no need to write that, grade 12. We know if you don't write anything, you mean your answer is 0. Then this 2 is the one that is applying the last rule, which says that coefficient multiplied by exponent, and then you subtract 1 from the exponent. So it's minus 1 times 2, which is minus 2x. From the exponent, you subtract 1. It's minus 1 minus 1, which is minus 2. Please always use your calculator in terms of addition to verify your answers. When you multiply, also use your calculator so that you don't do any sign mistake. And then now for the next one, remember we derive each term. We now move to the third term there. It's minus 2 times positive 1, which is negative or a minus 2 there. X. From the exponent, you subtract 1. That is the rule, grade 12. Then minus 2 minus 1 will give us a minus 3 then. Exponent. You can leave your answer there. Or if you want to be smart enough for those level 4 learners, you can leave this on top, minus 2, and take this to the denominator. It will be x to the power positive 2. Leave minus 2 on top, and then take x cubed to the denominator. It will be x to the power positive 3. No more minus 3 picture. And then this problem will worth 2 marks for both correct derivatives. Okay, the third type now. If you look at this type, you are having a denominator that is x plus 1. Remember, we were moving only if it is one term, we can move to the top. If you have 1 over x, you can write, or 2 over x, you can write as 2x to the power minus 1. Why? Because it's only one term, x. But in this case, we are having 2 terms. It's a binomial. We have 2 terms. There is no way, grade 12, you can take this and write as x plus 1 to the power minus 1. No, you can't do that. We do that only if we have what? Only one term on the denominator, right? In the case like this, that means there is a relationship between your numerator after factorizing with the denominator now. And then let's see now. If you look at this, this is a trinomial where you are factorizing. Okay? So if you look at factors of that, in that case, you need to do some factorization. If you are factorizing this, you will end up with 2 brackets. So this 2x is x squared is 2x times x. Those are the only factors of 2x squared. And then factors of 1 here is only plus 1 and plus 1. You can't have any other factors except that. 1 times 1 is 1. And then now on the denominator, remember we have that x plus 1, that will be x plus 1. Can you see grade 12? After factorizing now, you have something in common. So this x plus 1 bracket will cancel the x plus 1 in the denominator. So we are left with only 2x plus 1. Look at my notation. I'm not changing anything because I was busy what? Simplifying, not yet deriving. Okay, now I'm having a linear equation, a straight line. I can now start deriving. Okay, so I am telling you, I am now deriving. I am now applying the rules now. So now the rule says that if the exponent is 1, I am taking the coefficient as an answer. For this one, it's a constant value, the derivative is 0. Then my answer will just be equal to a 2. So first mark will be for factorizing, the second mark for ending up with 2x plus 1, the third mark for the derivative. So this problem will just work 3 marks. Right, let's look at this one. Find the derivative using the rule of differentiation. Look at the notation there. There is no equal sign. It's the dx into that particular fraction that is given to us. Right. Now we check that before we derive conditions. Can you see that you are having what? A variable in the denominator. We can't differentiate if we have that x cubed on the denominator. How many times do we have? Only 1. But because of those numerators there, we are having 2 on top. We can't just take this x cubed and bring it up there, because now it is a denominator to 2 terms. It's not the same as having 2 over x cubed grade 12. Can you see this is a variable in the denominator, but only to 1 term. That is why we can write it as 2 to the power x to the power 2x to the power minus 3. But if you look at this denominator is for 2 terms. We can't just move it to the top. All right. And then in this case, now what we will do, grade 12, is that we are going to leave that dx because we are not yet deriving. We are going to simplify this and share this denominator. What are we applying now? Remember, if I'm having 1 over 2 plus 3 over 2 there, I am applying the LCM method. I will look at my LCM is the same, is 2. Then if LCM is the same, you can just add the numerator there. Can you see that? Then now, initially this was 1 over 2 and 3 over 2. I am going to apply that principle in this fraction that we are having. So we are going to have x over x to the power 3 minus x squared over x to the power 3. Can you see grade 12? We now have 1 term on top, 1 term below. Then we can now apply the rules of exponents, or you can check how many x's do you have in top, and then on the bottom how many do you have there. So we are simplifying. We are actually simplifying this. So we have x to the power 1, and how many here? You have 3 x's. It's like we have x on top, and then denominator we are having 3 of them. So this x will cancel 1 there. Remember, there's a coefficient there. Then you'll be left with 1 over x squared. Can you see that? That means this x will cancel 1 here, then you'll be left with 2 of them. So we take on top, we'll be left with the coefficient 1. At the bottom, we are left with x squared minus. And then for this one, we are having x squared there. It will take x squared there, then you'll be left with x to the power 1. So the on top, you have 1. Denominator, you are left with x to the power 1 there. Right, we have now simplified this. After simplifying now, still you have a variable in the denominator. So we are going to take these variables to the top. So now we are not yet deriving grade 12. We are busy simplifying. Okay. Before we derive, we take this on top there. We'll be having 1x to the power minus 2 minus 1 x to the power minus 1, because this is to the power 1. It's only then that you can derive the term. Yes, happy now. We are now deriving, applying the rule that says an exponent multiplied by coefficient. It will be minus 2 times 1. Then this dx will disappear here. We don't write dx anymore. We write the straight answer, which is minus 2x to the power. We subtract 1 from the exponent. Minus 2 minus 1 is minus 3. Start again to the next term. A negative 1 times a negative 1 is a positive 1. And then from the exponent there, we subtract a 1, is a minus 1, which is minus 2. You are more than welcome to leave your answer there, or you can continue, leave minus 2 on top, take x to the power minus 3 to the denominator, will change the sign. Leave 1 on top, and then take x to the power minus 2 to the denominator, it will change the sign to the positive. That is the simplified part of the derivative of that particular function. Let's look at this one. Again, it's a different type here. In this type, we are bringing in the set. As you can see, we have the square root of t there. And then from the previous activity, we indicated that if we have one denominator and then we have two terms on top, we need to separate the terms now in terms of the denominator back to its original. So we are going to write this as s into t. That is the square root of t over t minus t over t. So now when you look at this now, we have a challenge of variable in the denominator. We have a challenge of the root sign. We can't derive before we deal with those two. Okay, so right, we are simplifying this now accordingly. This t is the same as t to the power. Remember, it's t to the power 1. It will be 1 over 2 because the square root sign is having that 2 that we don't write there. Over t. And then minus t divided by t, it goes one step. So those we can automatically write a minus 1 there. Okay, we still have a t there. That means if this t goes up there, it will be t to the power minus 1. So you can even apply the rules of exponents. If you are dividing the same base, you know that you subtract the exponent. That is your exponential rule. So now this will be s into t. I am still simplifying grade 12, not yet deriving. And then this will be t. Half minus 1, where does it come from? It comes from same base, subtract the exponents there. That is half minus 1. So half minus 1 is minus a half minus 1. I am not deriving. That is why I am bringing down that minus 1. So now, everything is sorted now. No more variables in the denominator, no more root sign. I can now start deriving. The derivative of s at t is equal to the exponent multiplied by the coefficient. Remember, there's a 1 there. Is minus half times 1 minus half t. From the minus half, we subtract a 1. That will be minus 1.5, of which is minus 3 over 2. Please always use your calculator to verify that your addition or your subtraction is correct. For minus 1, because it's a constant, the derivative will be a 0. That means this is your answer, Rachel. So the first mark will be for writing this in a simplified form. The second mark will be for the derivative of that one. Okay. Move on to the next question. Okay, grade 12. Can I give you 2 minutes and do this for me? Because this is a straightforward question now. We are having 3 terms on top with one variable in the denominator. Therefore, you can't just take upwards because you have 3 terms on top. Okay, follow the same method that I have just indicated to you to try to solve that one. 2 minutes for you to go through that. Okay, grade 12. Let's see how far did you go. Remember our WhatsApp number 079 454 9535. Right, let's see now. How far did you go with this one, grade 12? I hope you are all correct. Where do we start now? We are having a variable in the denominator. Before you derive, you must ensure that no variables on the denominator. And then how do we deal with this one? Because it's only one term, that means we are going to take it to its original, where we are separating now back to its LCM. This will be f at x equals to x cubed over x. Each term now is taking the denominator x minus 5x over x followed by 3 over x. That is your first step, grade 12. And then from here now, we cannot derive yet. Still, we have a variable in the denominator. So now we apply our rules of exponent. If we divide the same base, we subtract exponent. So now our base is x, then we subtract exponent, which will be 3 minus 1, which is 2, minus 5. The x will cancel in x, we are left with only minus 5. We take this x up there because we don't need any variables on the denominator. That will be 3x to the power what, grade 12? It was power positive 1. It will be now minus 1 because it is moving to the top. All right. Now everything is now sorted. No more variables in the denominator. We can now derive. The minute you start deriving, you indicate I am now deriving. My notation is saying so because it's now f derivative of x. Okay. Now let's apply the method. We are having exponent 2. It will be 2 times the coefficient 1 there. That is 2. X to the power 2 minus 1. That will be to the power 1. That is the correct derivative there. And then remember, this one is a constant value. The derivative of a constant is 0. We know that there's a 0 even if you don't indicate it, right? And then the last one, we are applying the third rule, which says minus 1 times 3 would be negative 3. X, subtract 1 from the exponent, minus 1 will be minus 2. So grade 12, that is your answer for that derivative. So the first mark will be for simplifying, second mark for deriving correctly, and the second correctly derived value there. And then this will be equals to 3 marks in all. I hope all of us managed to get that 3 marks. And then now the third problem. Be careful. Yes, you have variables a and x there, but you will be deriving directed by your function. It is saying derive in terms of x, okay? So you focus, your derivative must be on x. The minute it says that, that means it is making this a constant because you are not deriving in terms of a. Do you get me, Gretel? That a will be treated as a constant because we are deriving in terms of x. So now, we don't have fractions, we don't have variables in the denominator, we do not have a root sign that we need to get rid of, so we can go straight deriving the problem. Right, this will be f derivative of x. Can I derive a? No, because we are deriving in terms of x. So that a to the power 3 will give us a 0. We treat it as a constant value. I hope that is clear, grade 12. Right. Then for the second one, it will be in terms of x. Yes, x is there. Then it will be 3 times 0, 5. And then for that one, we'll end up with an answer that is minus 1, 5 x. And then we subtract 1 from the exponent. It will be to the power 2. Okay. And then we derive the last one. Minus 1 times minus 1 there. It's a positive 1x, and then minus 1 from the exponent, it will be minus 1, which is minus 2. Either you leave it like this, grade 12, or you can write minus 1, 5x squared plus a 1 over x to the power positive 2. So this problem with how many? 1, 2 marks if it is correctly derived. Moving on, in this case we are given determine f derivative at 1. If you are given f at x equal to minus 5x squared minus 8 there. But if you look at this statement, you need to understand what it is saying to you. Number one, it says derive because there's a dash that of a derivative there. And then after deriving, substitute your x with a 1. That is what it means to you. So you need to understand that now, greater. Derive your f at x and then substitute an x with a 1. Don't do it before you substitute. So we are going, before you derive, we are going to start by deriving. All right, we take that expression f at x equal to minus 5x squared minus 8. And then we are deriving that. We don't have any challenge. We go straight deriving. That will be 2 times minus 5. That is minus 10. We are now applying a rule, minus 10x. From the exponent, we subtract 1. Then we are left with x to the power 1. This one is a constant number. It gives us a 0. Then this is the derivative of that particular function, minus 10x. But we are looking at the derivative at x equals to 1. Yes, we are looking at the derivative at x equal to 1. That means wherever we are having an x, now after deriving, we are going to substitute a 1. That will be minus 10 into 1. So our derivative at x equals to 1 will be equal to a minus 10. Grade 12. This is taking us to a gradient of a tangent to a curve. This is the method that we use to determine the gradient of a tangent to this particular graph. At a certain point where x is equal to 1, it will be that minus 10. We will look at this later on when we are determining the equation of a tangent. Because a tangent is a straight line, it needs a gradient of a straight line. This method we also use when we are looking at the gradient of a tangent to a function at a particular point. Later on, we will be talking to this one. Right. The next problem then, we are given, we need to determine f derivative. Can you see that? We are looking at the f derivative at x equals to 2 now of this particular function. We can't substitute 2 before we derive. So we are going to start by deriving. Let us derive. Nothing to simplify. It is straight and forward. Then it will be 2 times the 1 there. That is 2x. We subtract 1. It will be to the power 1. This one is where we are having to the power 1. We derive, we take only the coefficient of x. This one is a constant value, then it will give a derivative that is equals to 0 there. Right, we have now derived our equation. We now look at f derivative of 2. Then we are going to substitute our x with that 2. Wherever we have an x, we now substitute a 2. Minus 4. Then now f derivative of 2 will be 2 times 2, which is 4 minus 4, give us a 0. Always use your calculator to check is your answer correct. The answer that you get there, remember, is the gradient of a tangent to that curve at a particular point given at x equal to 2. The next question, we are determining the derivative of g now. The function is the g function, no more f function. We've been talking f at x, f at x. In this case, we will be talking to g at x. But this is g at x where x is equal to 0. Right. Derive g and substitute x with a 0. We derive g function. And then now this will be 3 times 1, which is 3x, subtract a 1, that is 3 minus 1, which is a 2, first term. The next term is is supposed to be squared there, is 2 times 3, which is the 6. And then from 2 we minus the 1, that will be x to the power 1. This one is minus 5x. Remember, if it is to the power 1, we take the coefficient, that is minus 5. If it's a constant value, the derivative is 0. Then we don't write that 0. This is now the derivative of g at x. And then now we look at the derivative of g where x is equal to 0. That means wherever we have an x, we are going to substitute that with a 0. 6 into 0 minus 5. 3 times 0, 0. 6 times 0, 0. Therefore, g at 0 will give us a minus 4. As you can see that this is a negative gradient of a tangent. Remember, this is the method that you will be using when you determine the gradient of a tangent to the curve. Again, you are looking at a derivative, but in this case, our x is equal to minus 3. Derivative first of a g function, that will be 4 times 3, that will be 4, 8, 12, x, subtract 1 to the power 2. And then 2 times minus 1 minus 2, x, 2 minus 1 is a 1 there. It's a constant 3 value, derivative is 0. Then we don't write that 0, we know there's a 0 there. We are looking at g derivative when x is what? Grade 12 minus 3, that is 12 into minus 3 squared minus 2, x is minus 3. And then you put everything into your calculator and then straight to your answer, grade 12. And then this will give us how much now? It is 12 into 9, negative 2 times minus 3. That will give us plus 6. Okay, and then 9 times 12, 9 times 12, we are having 12 times 9. 9 times 2 is 18, carry 1. 9 times 1 is 9, plus 1 is 10. Then we have 108 plus 6 there. Please always use your calculator. We are now adding a 6 there. This will be 14,114. So that is the g at minus 3. So it gives us that big gradient, which is 114 there. Okay, continuing grade 12. If you look at this equation now, we have a challenge because it is saying xy is equal to something. Okay, but the question says determine dy dx. That means it says derive y in terms of x. That means it is already telling you that your equation must be y equals to something with x. So now we have a challenge because our equation is saying xy. So we need to get rid of this x from the side. How do we remove that, grade 12? We will be dividing by x both sides. So this x will cancel that, we'll be left with y happy now on the left. And then we have a 7x, that set form, we can write it as 1 over 2, that's square root. And then we have over x that we have created by dividing them. We have a variable in the denominator we can't derive immediately. So we will be having y, and then it's a 7x to the power half. Remember, when you we divide same base, we subtract exponent. This exponent is 1 there, it will be half minus 1 there. So we end up with 7x to the power minus half there. We have not yet derived. We were simplifying and getting rid of the variable in the denominator. Now everything now is linear. We can now start. It's on a straight line. We can now start deriving. So the notation will be dy dx because we now apply the rule that states exponent multiplied by the coefficient is 7 times negative half, which is minus 7 over 2. Always use your calculator. And then x to the power minus half minus 1, that will be minus 1.5, which is minus 3 over 2. That is your answer, grade 12. And then now followed by the next question. Again, can you see we have the same challenge there? But in this one, we are guided that to start by making y subject of the formula. That is the key to your solution, grade 12. So we are going to apply that. If we transpose this to that side, we'll be left with xy this side, of which the right hand side will now be 7x to the power 6 minus 2x to the power 3. This will change its sign to a negative as you transpose. And then now divide throughout by x because we need y equal to. Everything will be divided by x. Then x will cancel an x. We are left with y on the left. And then we have 7x, remember, is to the power 1. When you take this up, it will be 6 minus 1, then it's 5 there. Division of the same base, subtract exponent. That is why we say 6 minus 1. And then minus 2. This is x to the power 1. Division of the same base, subtract exponent. Therefore, this will be 3 minus 1, which is x to the power 2. Happy grade 12 is now y equals to, we can now apply the rules. Notation will be dy dx. 5 times 7 will be 35. Please use your calculator. X to the power 5 minus 1 is the 4. The next term is 2 times minus 2, which is minus 4. X subtract 1 is to the power 1. Therefore, it will be 1 mark for simplifying, 1 mark for the first derivative, and third mark for that one. Okay? Remember, y subject of the formula is 1 mark for question 1. And then hence find dy dx you are deriving. Okay, grade 12, it will be 1 mark for number 1. And then for number 2, it will be 2 marks for the derivative. I hope we are still together on that one. Okay, grade 12, that was the last problem for the day. I hope everything is clearly unfolded to you. And then this lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Thank you very much. See you next time.